A life without prayer is a life without power. Now I call upon Ms. Minusha MP, Ms. Kanimori C, Ms. Kaushika Rani of Departments of Physics, Chemistry and Maths to seek the blessings of the Almighty.
நீராறும் கடலுடுத்த நிலமடந்த கெழிலொழுகும் சீராறும் வதனமென திகழ் பரத கண்டமிதில் தெக்கணமும் மது சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிலமை திறமியந்து செயல்மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
It is better to bring in the light instead of fighting the darkness. Now, I request the dignitaries to light the Kuttuvilakku and grace this auspicious occasion. Thank you all. Now, we request the dignitaries to take over the dais.
An amazing teacher is hard to find, impossible to forget. Now I request Dr. S. Pungurali Head, Department of Physics, to welcome the gathering.
Good morning to all. First, I must thank to our management and principal sir for giving me the wonderful opportunity. I would like to add the meaning of synonym for simplicity is Mr. Anup Jaiswal. Such a wonderful soul, great man with a simple principle, dedication in work, creativity in passion, is our today's chief guest, Mr. Anup Jaiswal, IPS, former Director General of Police, Tamil Nadu, here. Sir, my hearty welcome to you and thank you for accepting our invitation and grace the occasion. A man with exemplary mission and vision and marching towards it is our principal and secretary, Dr. B.L. Shivakumar sir. Sir, we approached you to conduct the function and you makes it as festival. Thank you, sir. My hearty welcome to you, sir. My special welcome to Mr. Mutturaj, ASP sir, for accompanying with us to conduct this event. Special welcome to Mr. Suresh sir. And friendly welcome to Dr. N. Uma, Head Department of Maths, Dr. T. Sasikla, Head Department of Chemistry, for their continuous support to conduct this event. A warm welcome to all teachers and children from various schools to participate in the workshop. My hearty welcome to all the faculty members and students of Department of Physics, Chemistry and Maths. My welcome and special mention to Mr. Vivek from Maths Department, Dr. Tamarai Chelvan, Mr. Satish Kumar and Mr. Prasanna from Electronics Department and Mr. Prabhu Venkatesh, Mr. Santana Krishnan for their timely help. Once again, I welcome one and all present here. Thank you.
Thank you, ma'am, for your welcome note.
Leadership is not a position or title. It is an action and example. Now, I request our principal and secretary, Dr. B.L. Shivakumar sir, to deliver the presidential address.
Very good morning. At the outset, I would like to thank the chief guest of the day, Shri Anup Jaiswal, IPS. Sir, he was born in the 1955 and joined IPS in 1980. He was Superintendent of Police in Coimbatore and retired as a DGP of Police from Tamil Nadu. I don't want to take much of the time. I would like to thank Shri Anup Jaiswal. When our physics HOD approached sir, immediately accepted. And today he is going to make the most difficult subject, physics and maths, to look simple. That's why we have joined here. When I was in school, or maybe the students who are here, the most difficult subject for us would be physics and mathematics. Yes or no? But if we understand the concept, that is the most easy subject. So today we have a great person to demonstrate all the facts about physics in a funny way. I also take this opportunity to thank and welcome our well-wisher, Shri Mutturaj, ASP, and the students from all the school. Nearly 600 students from 20 more school have joined here. I hope this particular day, it will be a memorable day for each one of you. Thank you.
Thank you, sir.
Some gifts are big, others are small, but the ones that come from the heart are the best gifts. Now I request our Principal and Secretary, Dr. B.L. Sivakumar sir, to present the award, Exemplary Science Motivator for Young Mind, to our distinguished chief guest, Mr. Anup Jaiswal, former Director General of Police, Tamil Nadu. Thank you, sir.
Not all superheroes have caps. Some have passion towards teaching. Now, we request Dr. N. Uma, Head, Department of Mathematics, to introduce the chief guest of the day.
Good morning to all. I'm profoundly glad to introduce the chief guest of today's function, Mr. Anup Jaiswal, former Director General of Police. To demonstrate his eminent personality, I would like to quote the line from the Times of India. He is an IPS officer with a backbone, and his batchmates and subordinates agree. We are proud to have such a personality amidst us. We are proud to have you, sir. And then Mr. Anup Jaiswal also has a deep fascination for natural sciences, especially physics. All through the years, he has strived to prove that interest towards the subject and could be achieved by introducing the subject with some fun and frolic. With his understanding, he started looking for simple activities and experiment through which he can propagate complex concepts in science. Armed with these ideas and some simple tools, he have been visiting various schools and colleges in the state and outside and making presentations and demonstrations, primarily with the aim of raising the curiosity of the students and luring them to observe, think, and experiment. He has covered around more than 125 schools and colleges in the last few years. Each program takes about 2 to 3 hours, and he can accommodate over 200 students on various occasions. A YouTube channel under the banner of Theosophy Science Center has been launched with a link, Science at Play, Anup Jaiswal. The video are 6 to 7 minutes durations covering various themes. The ongoing theme is Science of Motion, and the presentation covers topics in school textbooks and more. His idea and motive is not only complementing the science education, but encourages children to explore beyond. So let us not wait for long. We'll go towards the session now with Mr. Anup Jaiswal. I would like to extend another information here. Sir's son is the associate professor in IIT Universe, Chennai. And so his family is all behind this science, basically physical science. So let us see all his experiments today.
Thank you, ma'am.
Better than 1,000 days of diligent study is one day with a great teacher. So we have one such eminent teacher among us today to ignite the young minds with the facts of science. Now we request Mr. Anup Jaiswal sir to take over the session. Please, sir.
And here? Okay, that's right. Okay. No, wait a minute. ये बैक में लगा यहाँ पॉकेट में लगा absolutely convenient. Kindly settle down. Can I have the free? It's the first time, see children, I'm not a teacher. So please bear with me. I'm not going to give a lot of lectures or anything like that on that. But I had some fun learning about science and observing things. I know there's a huge class. I'll be moving up and down, showing everything, whatever possible. Don't write down anything. Close your notebooks. Keep your pen in your pocket. This is not going to be a class where you have to write anything. And feel free to talk. Be happy, cheerful, nothing like that. I told you I am not a science teacher. I used to find the science classes when I was studying very boring. And I know you are also will be finding it very boring. Am I correct or not? You all agree that classes are very boring. The biggest fun in life is to cut the classes. Am I right or not? Everybody likes to cut the class. You can be on the side because there are too many children. I have to keep moving up and down to talk to them. Otherwise, they will all go off to sleep. Why don't you come in the front, most of you? Because there's so much empty chair. So easy for me to contain. Otherwise, I have to walk up to there. If you can push a bit ahead, I have to walk less. Now, the word science often fascinates you. This is the maximum limit. Huh? That's maximum limit. Acha, thank you. So this is the Lakshman Rekha I cannot cross. So kindly come in the front. Those who can come squeeze in because they have said this is the Lakshman Rekha of my mic. Are you able to hear me? Acha. Can I have the blackboard, whiteboard kept here? There's a lot of empty place. Why don't some people come in the front? Because I cannot walk up to there. They say, okay, my mic will not. Inge bachanga. Bas inge. Get in, settle fast. I wanted this magnet is there. ये निकालो ये मैग्नेट और 2-3 बुक्स रखेंगे ताकि वो डब्बा है ना एक हाँ ओके keep it here. Now please settle down. I think to keep your attention towards me, instead of talking, I'll show you something to begin with. Very simple. And those of you can think and answer, a principal sir has assured me some reward is there. But anyway, not working for the reward, just see the fun and tell me what happens, what is happening. I need some student to help me. Anybody likes to come forward? What about you? Come. Be here. Just sit down fast. Okay, be here. The rest of you sit down. Not many, not. I'll call you again. You be seated here somewhere. Listen, children, just settle down. Please clear the way. Otherwise, you are obstructing me. Be on the side. The purpose will be lost if the children are not able to see me. Forget the photography for a while. Enough photo. Now, just to capture your attention, I'm going to do a very simple experiment in front of you. I like it very much, and it is so simple that you will laugh at it. But yet, one of the greatest scientists of the world performed it, and the conclusion drawn from the experiment were fascinating. Very simple experiment. Can you see in the last? Raise your hand. Can you see in the last? Raise your hand. I've got an ordinary plastic glass. Very, very ordinary plastic glass. Remember, this is not a class of magic. No tricks. It is our class of science. Whatever I tell you, believe in it. It is not that I'll be hiding something up my sleeve and doing something and then you'll look for it. No, everything is very simple. I'm not a magician. But most of the experiments will look like magic. This is a very ordinary glass made of plastic. There's a bottle of water there, no? No, leave that water. What's your good name?
Priyadarshini.
Priyadarshini is good. Keep it there. Priyadarshini, you go and fill the water. I'm asking Priyadarshini to fill the water till the top, up to the top, and bring it here. Don't drop the water, otherwise I'll ask you to go back. Fill it till the brink, last drop, fill it up. I have asked for a very simple work. I have given Priyadarshini an ordinary plastic glass and asked her to fill water in it up to the brim. Do you follow? If you shake your head or just say yes, I'll know that you're understanding. Very simple thing. You dropped it. Fill it again. Tell me, why is the water falling? She is bringing the water like this, very carefully, but yes, the water falls. Why? Anybody? Make a guess. What is that? Shake of the hand. If hand shakes, water has to fall. But why? These are people, you will be saying this man is mad. I take water in my hand, I shake it, it falls. Okay, I believe that. Now the water has not fallen. You have to come very carefully. Stand here, just stand for a while. You have all seen a very simple thing I am talking, that if you have a glass of water full to the brim in your hand, if you shake your hand a bit, the water falls is natural. Why this idiot is talking like this? But I'll show you something more. I will ask Priyadarshini, it's a simple unjal. Made out of, I went to a school, they gave me a memento, I broke the memento, used the plastic here. I got a rope from my wife hanging clothes. Yes, that is the correct thing, because I use only material available in the house, because she doesn't give me money. So that's how. So I will ask Priyadarshini to keep the water gently, very gently on this unjal. Very gently, don't let it fall. Ah, good. Now that I got the, move away. I'll just slowly shake the bottle. It will be shaking. Not a drop of water is falling. Don't clap, anybody can do it. But the question is, why is the water not falling? You're telling me, if you shake, the water will fall. But I'm shaking it here. The glass is becoming horizontal. The glass is vertical, it becomes horizontal. But no water is falling. Somebody was telling, tell me.
Answer is centrifugal force.
Huh?
Centrifugal force.
Oh, very brilliant but wrong. Why? This is what happens when you read too much and don't think. I'll tell you why he is wrong. Centrifugal force is applicable only when the body is moving, V square upon R. I'm not going to the mathematics. Now this unjal comes here, stops. What is the velocity here? What is the velocity? 0. Centrifugal force is 0. That's why I said, don't be in a hurry to answer by memory. Think, it's so simple an experiment. Anybody else wants to see it? I will ask somebody to come and do it. You will think this man is a tricky man. There's water here, ordinary glass. You're going to shake it. Water is not falling. Why? Tell me. Balance is very good. Try. If I keep your glass of water in your hand, make you do like this, will you do? Good, try. I'm very happy you're trying. That is what is required in science. Anybody else who wants to try? Anybody else who wants to try and answer? Tell me. Surface is flat, your hand is flat. I'm going to keep it in your hand, move it. It will fall immediately. You saw Priyadarshini? It was not. It's a simple physics. Anybody who has learned physics in, tell me. It's good you're trying. I'm happy. But answer is much more simpler. Very good. You know about center of mass, but that's not required here. I'm happy. Try. That is what is important. Centripetal. He told centrifugal. You are saying centripetal. Center of mass. All these are words. I'll tell you what is the meaning of the words. Moment of inertia. Another word. Useless word. Now, children, just pay attention. You saw, and you have read in the books, my friend told centrifugal force. Yes, he was right, not for this, for something else. What was he right for? Let's see. If I take this glass of water and do like this. See, it doesn't matter. A piece of, just wipe it. You fill it again, Priyadarshini. So you saw the water going round and round. That is where it is right. All the books, textbooks talk about it. Centrifugal force. But my problem was not that. You are thinking with memory. Come fast. I don't have time to waste, Priyadarshini. Even if you drop now, doesn't matter. What was it? Anybody else wants to try before I answer? Because I will not be answering later on. Other problems I will not answer. You have to work it out. But most of them are simple, but difficult to answer. I posed this question before even IIT professors. And I was shocked. Many could not answer. And the answer is so simple. Listen to it. When I'm shaking, the water, I say, is not falling. No. The water is falling, but the glass is also falling. And Galileo gave the theory long back. Gravity acts equally on everything. Earlier it was believed heavy things fall faster, light things fall slowly. That's what you observe in life. You drop a piece of paper and stone, paper comes down slowly, stone comes fast, but not because of that, because of the air. It was first time Galileo, in the 17th century scientist, who said, no, gravity acts equally on everything, liquid, gas, whatever it is. So here what happens, when the glass is here, the water starts falling. But with the same speed, the glass is also falling, the unjal is also falling, everything is falling with the same speed. Because gravity acts equally on everything, they will not separate. When you are keeping on the hand, when you are shaking, water is controlled by gravity because it's free, and the glass is held by your muscle, mismatch. They separate. What is falling is only separation of the glass and water. Now it looks very easy, no? That is what is important. First, try to understand the concept. Rest mathematics, speed of falling, that will become very easy if you understand the concept behind it. But it took 2000 years of learning from Aristotle to Galileo, all the great scientists, to come to this conclusion about gravity. Now I'll come to now a bit of talking, then we'll go again for the next experiment. You have a good handwriting? Little bit handwriting, not good. Anyway, I have a very poor handwriting. I'll start with now some simple writing, 1 or 2 minutes, next demonstration. Can you write A, B, C, you write? I'll say, right? A, B, C, big A, capital A, B, C, you write T, T here, write T here. This is good. These are few alphabets, that's all. Listen to me carefully, it's a very interesting thing again like you. What is the meaning of the word A? Can anybody tell me the meaning? A. What is that? I'm asking meaning. Meaning is when you say A, does any image come in your mind? Nothing. Apple comes in your mind, I know that. Because you are taught in the childhood. Very good. There's another word called T. Any word, any meaning? T sometimes means TEA. You can think about the cup of tea. But tea as such has no meaning. It's just a sound. Am I right or wrong? There's a word called C. Any meaning? No. But please write here, capital here, TCA. Underline it. Full. Now I have got 3 letters combined. TCA. Any meaning? No meaning. Now you write CAT. Very interesting, very simply follow. You got the word CAT. What is the... Oh, all of you are happy. Because each letter of cat has no meaning. But when you combine them in a particular format, suddenly a picture comes in your mind. It can be a small cat or a big cat or a running cat or dying cat, whatever it may be. But you get a meaning. Science is also like that. I'll show you the alphabets of science which are meaningless. Yet when you combine them, start getting meaning. Rub it off. In the last, are you able to hear me? Last. Are they able to see on the board? Anyone? Please raise your hand if you are not able to, if you are able to hear me. You are able to hear me. I'll come most at Arden back here when I'm giving the demonstration. Science also, we have got meaningless words, which are the alphabets of science. Please write in capital space. Space, S-P-A-C-E. Write it dark, huh? S-P-A-C-E. Next word, you write matter. Matter. I'm just coming to some very simple word, matter. Third, write time. Time. We'll stop at here. No, you must have heard all these words. Everyone knows. What is space? You all hear space, space. What is it? What meaning? Tell me. The universe and the gap between what? Very good. Space you are defining as a gap between two matter. You have to require matter to define space, correct? Like in cat, C does not have a meaning. It has to take another word combined together to get a meaning. Here also space has no meaning. It has to search for another word called matter. What is matter then? Anybody who can tell me what is matter? The definition given is matter is which occupies space. Isn't it?
Occupies space.
Is matter. Very good. Now I will tell you a very funny thing. I live in Chennai. Somebody asked me, sir, where is your house? I told him, it is opposite the post office. He said, very good, sir, but where is the post office? Opposite my house. Where are the both? Opposite each other. How wise have you become about my address? You will never know my address then. That is where I tell you, space is defined in terms of matter. Matter is defined in terms of space. What do you understand by it? That is where experience counts. There are certain things you directly experience but you have no word. Suppose you are reading a lot of books. I want you to tell me, have you eaten an Alfonso mango? He said, no, sir. Can you find the taste of Alfonso mango? Yes, sir. Library poe mere book paakranga. Can any book tell you what is the taste of a mango? Book is sweet. Sugar is sweet, mango is sweet, pineapple is sweet. But pineapple is so different from mango and from sugar. But ella mein book le sweet, sweet, sweet. How do you know the taste of mango? By eating it. That is by experiencing it. Most of the science you try to learn from books, you will never learn. There are certain things you have to experience. Feel it in your bones. By experimenting, by observing, by playing, then only science becomes very easy. Evolution atomic table, this table, that table, day and night, laws of motion, Newton's laws of motion, Newton's laws of gravity, meaningless. Even it was meaningless to Newton himself. I'm not joking, I'll quote it now. So after this brief introduction, let's rub it off. Kindly sit down. After this brief introduction, I'll now come to a small formal way of talking about science. When I came to this college, I was really overwhelmed because of this massive strength, organization, hall. To tell you frankly, I'm a bit frightened. To have so many children together to attend into a class. But anyway, I met some students of physics, some students of chemistry, mathematics, maybe some biology. We are all segregated. But in life, everything is one. I take a deep breath. Air goes in, physics. It is absorbed by the blood, metabolism takes place, chemistry. The cells are functioning on it, biology. And if you work out what is the ratio of oxygen and carbon dioxide, you need a mathematician. But one work. Physics, chemistry, biology, mathematics. But in the classroom, physics ka gange pono, biology ka gange pono, you are segregated. And that is why many times we are not able to understand. I am very good in mathematics, physics teriade. I am very good in physics, biology teriade. The problem is you are concentrating too much on your books and not seeing the next few experiments and all that which I am going to show. All have been prepared in my own house from the broken material in my house. So first I'll do some physics, I'll then go to chemistry and then join them together. We'll have some fun. I need another girl or a boy whose handwriting is good who can write here. Somebody will come. Just come. Be here. Children, please remember one thing. Science as a subject has always been there with human mind. It was earlier called natural philosophy. When it was a natural philosophy, everything was combined. Medicine, physics, mathematics. Pythagoras was a great mathematician. You must have heard about the Pythagoras theorem. But he was also a medicine man. He was also a philosopher, literature writer. This compartmentalization has led to the falling levels of education. As individuals are very poor in education, but as a combined society, we are going to the moon. But if you go to a rocket launching station, ISRO, you call one scientist and talk to him, sir, how do you tell me how this rocket goes and lands on moon? He says, sir, naan air conditioning mattum patri sol mudiyum, landing patri sol mudiyade. You go to another scientist, sir, you tell me how does the rocket lands on moon? You are a part of ISRO. No, sir, I only look after the fuel. I have no idea about the landing. What happens? You find all the scientists working for that rocket are individually ignorant about the rocket. But in combined together, the rocket is going and landing on the moon. This is what has happened in most of our classrooms and society, our institutions. We are all specialists. You go to a doctor, sir, I have a problem in my right eye. He will say, no, I am a left eye specialist. Right eye, ange poi paranga. That has led to certain fracturing of the thing. That is essential also. To go in details is not possible to go in details of everything. But one important thing, don't lose the sight of the whole. Go to the individual. But here I'll show you what was the whole from the ancient times. When mankind was watching things happening, there were primarily few things which everybody notices. Air, water, or fluid, the earth, fire. Fire was one of the most fascinating things, whether a jungle fire or something. Nowadays, children never see fire because everything is happening electronically. Light is because of electronics, but fire was another fascinating. Just write these four things, air, water, and I'll base my experiments in this broad category of old days. Because these categories combine everything together. कुछ हुआ है? कुछ बना है? हाँ, हाँ, पर अभी कुछ बना नहीं है। हाँ, इतना यहाँ बना है, ये बना। हाँ, हाँ, छोड़ रहने दो, थोड़ा सा 2 ड्रॉप डाल दो ऊपर से। That's all. Not land, earth. Earth means solid objects. earth. And then the next observation was, which fascinated mankind, was motion. The stars were moving around the earth. The moon was moving. The sun was going from east to west daily, day in and out it was moving. Motion was another area which fascinated mankind. Why? Inge sun porar. It comes out here in the morning, goes there in the night. Night inge poitare theriyade. Next day again, back again. It was not a simple question to answer. You know, in textbook, earth is round, rotating. It's not that simple. I'll tell you why. Till Copernicus, a famous scientist, came, people believed the earth is stationary, everything else is moving around the sun. Am I right or wrong? Speak loudly, I'll show you the surprise. Copernicus, Galileo said, sun is stationary, earth, planet, Venus, Mars, all are going around the sun, right? Any doubt? What is the belief in 20th century? Which is correct? Earth moving around the sun or the sun moving around the earth? Which is correct? Anybody has a different view? There are two views. Earth moving around the sun and sun moving around the earth. Which is correct? And I tell you very boldly, you're totally wrong. I'll show you why. Tell me.
Sir,
Interlock? The speaker, I'm not able to hear. Tell you again, my son.
सर सन ईयर के எல்லா பிளாनेट्स में इंटरलॉक ஆகி சுத்திட்டு இருக்கும் லாக் ஆகி சுத்திட்டு இருக்கும்
Interlock. What is the word inter? What did you say? Speak the word. Spell.
सर इंटरलॉक
Interlock. That's what they are interlocked. They are interlocked. That's correct. But which is moving around which? Earth is moving around the sun or the sun is moving around the earth? Both.
yes sir.
Why you say that?
Sir, I have heard somewhere the sun also in some years it rotates around the earth.
Some years. Okay.
No sir.
You are right, but your answer is slightly wrong.
Sir, actually, sun is going around the galaxy.
Oh, that is different. No, sometimes children give us such a surprising right answer for wrong reason. I'm very happy. You are trying, I'm very happy. That is what is the spirit of science. Try, think. You may be wrong, parvaile.
Sir,
Tell me.
when the earth is rotating around the sun,
It's not rotating, revolving around the sun.
yes sir, revolving sir, it's not revolving like this sir.
Huh?
That is also moving no, sir.
It's moving, but I'm telling you, which is going around which? Whether the earth is going around the sun or the sun is going around the earth, which is correct? Daily you see sun going around the earth, don't you see that?
Yes sir.
But you say, no, that up I came.
Sir, no sir, the earth is also rotating and it's revolving around the sun sir.
Earth is revolving around the sun, sun is not revolving around the earth.
Sir, because the earth is rotating,
No rotation I'm talking. I'll tell you a very interesting thing. Children, just here. I got good answers, right answers with wrong reasoning. And see, one of the greatest revolution for mankind was Copernicus. Before Copernicus, there was a famous astronomer called Ptolemy. He had a model of the universe, Earth in the center, everything going around the Earth. And it was so accurate a model that he predicted all the movements. When will there eclipse? What will be the position of this planet? Everything was predicted by Ptolemy correctly. There were circles within circles. It was called an empirical formula. Adjusting everything slowly over the years, finally got a model. Earth in the center, everything going around. Ptolemy's model is still used. Have you anybody been to any what you call planetarium? Anybody has seen a planetarium? There are big cameras there which work on Ptolemy's model. Then came Copernicus and Galileo, who said, no. They worked out mathematically and they said, no, it is the sun which is stationary and earth goes around there. And it was believed, it was fine, correct. unless the beginning of 20th century, another mad scientist came into place. Can anybody tell me the name of the scientist? His name was Albert Einstein. He gave the theory of general relativity, general theory of relativity, or theory of general relativity. That is the correct. According to which theory, there is no gravity. This concept of gravity is the wrong thing. Wherever there is a mass, the space and time both get curved. You will not understand immediately what is the meaning of curvature of space and time, but that is what he said. And he said if there is no gravity, all motion, whether accelerated are relative. If it is mathematically easy for you to work your problem by keeping the sun in the center, do it. If it is easy for you to work with a model with the earth in the center, do it, because no motion is absolute. Each one is relative. It will not be very clear in one day, because I am talking something which is against what you have studied. Because all in your books you have studied, because our books stopped at 19th century and beginning of 20th century, because special theory of relativity and theory of general relativity was never accepted by the world. That's why Einstein never got a Nobel Prize for relativity. It was only in the late 20th century, suddenly when the rocket started going to space, when the GPS system came, they found the only way to understand the working was by through relativity. So I'm leaving it as a question mark. Many of you will be curious. Read what is relativity. All motion, accelerated, simple motion, all are relative only. And that is one of the biggest learning of mankind, that all motion is relative. But if I throw a ball, I know I threw it. How is it relative? I only threw the ball. Science does not deal with living beings. Physical sciences, by and large, do not know what is life. So, I'll come back. Now you write it, the laws of motion. And we'll do all the experiments next. Motion, right motion. What are the laws of motion? Can you tell me very briefly? There are 3 laws which cover all motion. Anybody can tell 3 laws? Yes, huh? This is Newton's law. Huh? Law of inertia, law of conservation of momentum, and action and equal and opposite reaction. Am I right? You're saying that only in Tamil. Tell me what you are telling. Speak it out. Very good. So just speak. Don't be afraid. Huh? What is that? Speak. What are the laws of motion? Michael Persinger.
இயக்கத்தின் நிலைமம் ஓய்வில் நிலைமம் திசையில் நிலைமம்.
What is that meaning? Huh? What is the meaning? Anybody who can translate and tell me what she said? What does she say?
Inertia of motion, inertia of rest, inertia of direction.
Anybody else who knows all the 3 laws of motion? Anybody?
Sir, Newton's first law, second law, and third law.
Very good. Wrong.
Law of inertia, law of conservation of linear momentum, Newton's third law.
You have been right in 2. Law of inertia, law of Newton's. The Newton's second, listen to me, the Newton's second law, which talks about the conservation of linear momentum, covers both the side. The inertia is covered because this says change in momentum occurs when there is a force. So when there is no force, no change in momentum, inertia will continue. Right?
Yes.
Action and reaction again covered by the second law. So one is conservation of momentum, second is conservation of energy, third.
Conservation of energy.
Very good. At least you get a reward for your one or two. What is your name?
Sadhana. Sadhana Shri.
Sadhana Shri. I request the principal ma'am to give, principal sir to give a book to her, because that's right. Sadhana Shri, run. Take a pen to yourself. Now come, the third law is still missing. Conservation of mass is not part of the momentum. Conservation of energy deals with conservation of mass. Am I right or wrong? Einstein said E is equal to mc square. Mass and energy are correlated. Hence, conservation of energy means conservation of mass. Part of it. Anyway, the third law. Right, please rub it off. The three laws of motion. And I am right. First law, conservation of energy. Conservation of energy, write it. एक डंडा चाहिए, इसमें स्लिप कर जाएगा ना, कब कहाँ है ऐसा? I'll try in this. Conservation of energy. Second is conservation of linear momentum. I'm coming back to chemistry after some time because a lot of chemistry children are getting impatient. And mathematics also. Conservation of linear momentum. Momentum. Write fast, we don't have to waste time. Momentum, understood. And what is the third? Anybody can tell me? One of angular momentum. One more prize for her. If you understand these three concepts, conservation of energy, conservation of linear momentum, and conservation of angular momentum, entire book of your chapter, 50% is only on motion in all your books. Even when you are dealing with charges, moment, currents and all that, there is a lot of talk about motion because motors will move. If you understand these three concepts, 30 to 40% of your physics becomes child's play. But understanding the three concepts is difficult. I'll demonstrate why. You've written down the three concepts? Very good. Now we'll have a demonstration of angular momentum, linear momentum, and conservation of energy. What is energy? Anybody who can define energy apart from his textbook capacity to do work, don't say that.
Energy cannot be created nor be destroyed.
Energy cannot be created or destroyed. That is the meaning of conservation of energy. But what is energy? What is energy?
Ability to do work.
I said don't give that answer. Capacity to do work, I don't want that answer. Any other definition of energy? Amount of, then I'll ask the question, what is force? Then you explain in terms of energy and energy in terms of force. If you say energy is capacity to do work, I'll ask you what is work. Then you say work is capacity to use energy. Ungal weed enger ke post office ke munale, post office enger ungal weed ke munale, random enger kanga. You understand that sort of a definition? You all your textbook carry like that.
Work done to bring the object from one place to another.
Move an object from one place to another. Maybe, but not very good. Anyway, you're good. I'm happy. See, the energy is something again like the taste of the mango. No book you will find in the world today which can really define energy. Earlier it was believed kinetic energy, potential energy, then heat energy. Later came, no, heat is also the motion of molecules, and it was understood. Then nuclear energy. Nuclear energy from where? Because the mass is getting lost, the mass was converted into energy. So mass is also energy. It was always a confusion, and it keeps on progressing. But that's why all the books shy away from defining energy, but they use the word energy daily. no energy can be created. Now I'm going to give you a very beautiful demonstration of firing a gun. I brought a gun. I'll fire it here. You have to find out from where the bullet got the energy. You understand my question? All of you look carefully because some of you at the back, I'll ask the camera to focus. I'll be setting up a gun. I'll be setting up a gun and firing a bullet. And you have to look carefully because in normal gun, say a rifle, there's a chemical powder inside. Correct? The chemical powder burns and after burning produces a lot of gases which expand and push the bullet. Chemical energy or the potential energy of the chemicals converted into kinetic energy of gases which pushes the bullet, right? When you're going to some fair, you got air guns. You fire at the balloon. Have you seen it? You load the gun first, there is a spring inside, you tighten the spring, put a pellet, load it back and fire. The energy of the spring gives it to the... But I am going to show you a gun which has no spring, no chemical, but it fires the bullet. The problem is to find out from where did the bullet got the energy. Look carefully, it's a very interesting experiment. It is called the Gauss gun. Children, kindly sit down. Because डिब्बे में है ना. Remove everything. Remove everything. Please, cameraman, you have to focus on the table. I've got a very simple gun. This is the barrel of the gun. Again, in my house, we hang curtains here. So when the curtains were being made, this piece was left out. I found it as the barrel of my gun. I'm not joking. I'm going to really fire a bullet to you before you. You understand this? I keep it here. Can you everybody see in the last? I keep the barrel. Now I'm bringing the charge. See, I've got two small magnets in my hand. Can you see it, camera? Can you show them? Can you see in the last? Two magnets. Huh? Can you see these two magnets, two small piece of magnets? I'll show you why I'm saying it's a magnet. I keep the magnet here, one piece, just like that, and keeping the other piece here. I've got a lot of magnets in my pocket. I have to take it out. I've got these bullets, very heavy pellets. Somebody in the back can pick it up for me. I'm sending it there. Should I throw it? Pick it up. Get to me. It's a very heavy ball. Can you see it on the magnet? You got it? Thank you. They're very heavy pellets, far heavier than your air gun pellets. You can see it. And they are non-magnetic. I will be firing one of these pellets like a bullet with the help of a magnet. I am giving my friend five pellets. Stick pen. Two. Stick it. 1, 2, 3, 4, 5. I bring it back. Hold it in your hand. Put the pellets. Again 5. Slowly, inge vachinga. 2, 3, 4, 5. See, are you able to see it? Any other pellet is there? I keep it this as a target. See, the magnet's job is to attract things. Everything is attracted, see? But surprisingly, now what I'll do, watch carefully everybody at this. One magnet, 5 pellets. One magnet, 5 pellets. I've kept a target here. Just close it. In dabba mein leve. Now you can see more clearly. I've got one pallet here. I'm just going to keep the pallet. Inge, watch carefully. I will keep the pallet here. Did you see it? Again, please, again, see it carefully. One, two, three, 4, 5. What I'm doing, I can make a row chain because I space availability and visibility I'm giving. I've got a magnet here, I've got a magnet here. I'm taking one heavy pellet, I'll just keep it here. It is attracting the magnet, it stops there, but suddenly all other bullets will start flying away from the magnet. There is a magnet here, there is a magnet here. Just see it carefully. I'm just keeping it here. I'm not pushing. Very fast. Did you observe it or not? That's important thing. The question arises, this final bullet which came out, which was able to push this box, hit it. Where did it get the energy? Try. Okay.
Sir, when the magnets are placed under with that bullet, sir, the electric field changes, so it won't hit.
No. You have picked up a lot of words, like our space-time meaningless words. And think about it. See, magnet is supposed to attract. I keep the magnet, it gets attracted. But other thing on the other side of the magnet, they fly away. Anybody trying, where did the energy come from?
Sir, the purpose of magnet, as you said, it is attracting, but the keep and bullets are non-magnetic, so the force is opposite and flying over there.
Non-magnetic will not be opposite. If an iron piece is non-magnetic, it will be attracted towards magnet.
Sir, but
all are not, these are non-magnetic balls.
Non-magnetic ball touches that front will go, sir, and it will.
But why did the other thing fly away? From where the energy came for that big ball to go and hit? Huh? Static friction. All words. Anybody can think, because you said energy cannot be created, energy cannot be destroyed. I have not given any energy, I just kept the ball. It got attracted towards the magnet. And suddenly the last ball flew away.
Excuse me, sir.
Where are you? Tell me. I am coming there, don't worry. Tell me. come in the mic, come here, you can speak to everyone. Shall speak.
So when the pellet attracts the magnet, the forces will combine. And the last pellet will array the all forces, and the bottle will.
No, my question is simple. The last pellet has a lot of energy.
Conservation of.
So from where did you get the energy? Conservation of energy means if something has gained energy, something should lose energy. Am I right or wrong? Who lost energy?
First pellet.
The first pellet, I never pushed it. Where is the energy?
The magnet.
Pulled it.
Pulled it. And on the pellet patina, for a moment the third
So it has got energy. How did the last get energy? From where? Who lost the energy? Tell me where. See, to get kinetic energy, somebody should lose the energy.
Vibration.
Tell me, my friend, who is there?
Vibration.
Speak.
Vibration.
Vibration, nothing, it's not so difficult, it's very simple. When I tell you your answer, you'll beat your head. Evalu simple, Dana. Tell me. Magnet to the... Magnet has got energy? Does magnet has energy? So I'll come to that concept. How do you say magnet has got? If magnet had energy, you can keep using the energy. Magnet remains the same. Isn't it?
Sir.
I'll tell you a very interesting thing why I came up with it. First, please pay attention. Energy is a very difficult subject to handle for teachers and everyone. I am in the space. I am in a rocket. One rocket is going in front of me very fast. What will I say? That rocket has got very high kinetic energy. Correct? The person sitting in the rocket, other rocket will say, I am stationary. That rocket is going very fast. Correct? So, one will say, you have energy. The other person will say, you have energy. Kinetic energy. Who has the kinetic energy? You understand my question? Very simple. You are in a rocket. You observe another rocket going very fast in front of you. You will say, oh, that rocket has got very high kinetic energy. Correct? There's a person sitting in that rocket. He will see you going very fast the other way. Relativity of motion. He will say, oh, that rocket, you have got a lot of kinetic energy. But who has energy? Both are moving, both are stationary from each other's point of view. From my point of view, I am stationary. He is moving. From his point of view, he is stationary. I am moving. Who has got the energy? Both have no energy. The relation has energy. All energy is a relational term. Kinetic energy is a relation of one moving body to another body because of movement. Potential energy is energy of one body in presence of another body because of location. I have a ball here, the earth is here, the ball has potential energy. If the earth is not there, the ball will not have any potential energy. It is in relation to another body. I have a ball here and a magnet here. The ball has potential energy in relation to the magnet. Magnet doesn't have energy. So when I am losing the ball is losing potential energy relating to the magnet. And that energy is getting converted into kinetic energy. Suppose I want to go back, I have to pull it out. Again I am supplying energy. Pulling is, my muscular energy is going inside, my chemical energy is going to the magnet, and magnet goes back, the ball goes back. Please remember, all energy is a relational concept between two people, two bodies, not separate. Often we try to think of energy beyond relation, like space and matter are combined. There is no space without matter. And there cannot be matter without space, because matter is what occupies space. Similarly, time. Some change has to occur. What is time? This change comes first, this change came last. But who observes the change? A ball cannot observe a change. It is a living being, a human being has to observe. A conscious life has to be there to see the movement. For example, I want the children just to pay attention before I go to the next experiment. Very simple concept I am telling you. This can in my hand, I say it is moving. What does movement means? It was there, it is here, correct? It was there, it is here, then you call a movement. Am I right or wrong? But it was there is a question of my memory. Suppose I never had a memory. I will never know it was there because it is a past thing. I can only say it is here now. And memory is only belongs to a conscious being. The universe is there because I am there. Aham Brahmasi. I am the Brahma. If I am not there, the universe is not there. This was told by sages of long back, not in terms of physics. But they say, each one of us, we create our own universe. I'll not go into it, it will confuse more. Now coming to the third aspect, conservation of angular momentum. This is a very fascinating concept. And I'll show you, before that, who was writing? There are two more words you can write. Motion is governed by inertia, something is moving, and there are two things called forces. Though one force has been denied now, gravity, but two forces. What are the two forces in the universe normally you observe? One is called electromagnetic force because electricity and magnetism are combined. Other is gravity. There are two other forces in nature, but day and night we don't observe. That is called the weak nuclear forces and the strong nuclear forces, but they are inside the nucleus only, not observed outside. So we will not talk about them. The total physics is covered by these things. Right, please? Gravity, gravitational force, and electromagnetic force. And your physics chapter of motion, most of the chapter of physics, a large part of thermodynamics in chemistry is over. These are the 5 lines which cover virtually the entire thing. Then comes area which is totally away from this is light. Light, you understand? Nobody knows what it is, whether it's matter, whether it's energy. It's moving, but nothing can move beyond faster than light. Those are very complex. I'll come to that also. But light is another area of fascination. And light is also connected with electromagnetic force. So this brings, kindly sit down. This is the, and for 300-400 years, physics and other parts of natural sciences were confined only to this 5 lines which you have written. If you have these concepts clear in your mind, qualitatively, physics becomes very, very easy. Then you apply mathematics to write it in precise term. What will be the acceleration? What will be the force? But the basic concept has to be clear. Once you know how a balance works, weighing becomes very easy. Then you know I have to put 1 kg here, 2 kg here, whatever. That is mathematics. But the concept of entire, I'll now come to the third law of conservation of angular momentum. Pencil. Pencil. I'm telling pencil. I'll do with this. I've got a very interesting experiment now. I've got a cup. Everybody can see this cup? And a string tied to the cup. And I've got a very small weight here to keep the string tight. That's all. And I'm going to do an experiment which will look like magic. Just watch. Where is the pencil? Cameraman, kindly focus at me because children can see there. I've got this cup hanging on a string. Can you see? In the last. Can you see me? I'll come there and demonstrate there also. I have taken an ordinary pencil. I'll hang the cup on this pencil. You see? If I leave it, what happens to the cup? If I leave the string, what will happen to the cup? It has bound to fall down and break. Am I right or wrong? I will request the children to speak a bit loudly. It gives me courage. Anyway, okay. I'm a bit nervous about it. Thank you. You've been kind. Just watch. I leave it. How many pieces it will break in? Can anybody tell? See. So 1, 2, 3. One, 2, 3, 4, 5, 6, 7, 8 times it has gone. Again, I'll try. Nothing I'm doing. I'm not pushing. I'll ask my friend to come here. You come. You do the experiment and break the cup. Hold the pencil. She will do it because you think I'm doing a trick. Stand over here. Hang that. Don't slide it like this. It will slide down. Keep it a bit up. And don't press the... Keep it up. Correct? Bring your other hand. Hold it. Hold it. Hold it here. Hold it. Oh, your hand is small. I want someone tall. Wait a minute. Come. You hold the pencil in that hand. Hold it tight. Bring your hand here. Your hand is also small. No, it will break. I want somebody else. Suresh, you come. No, you come from here. You come. Now, cameraman here. He is a tall man. Hold the pencil and the hand. Don't put it like this because it will slide. Put it slightly up. Don't hold it. Can you hold it here? Hold it here. I'll tell you. Watch. Leave that hand. You are holding like this outside. See, very simple. I don't know why anybody cannot understand. See, simple. This is the there. Move out. Go to the camera. You just see. Nothing I'm doing. Why is the cup not falling down? Why is winding itself so many times? Anybody wants to try can take it. I'll try it there. You can break the cup. I don't mind. It's an old cup. You want to try? Try for them. Come here. Let everybody see. My friend, be careful. Like a scientist you have to do. Don't break the cup before that. Keep your finger is slightly up. Don't put the... It's a big pencil here. Pull it. Good. I'll show you. Very good. Give him a hand. Just see. Very simple. Isn't it? And it will go around many times with very high speed. Just see, I'm doing nothing, no trick. Many cinema you see na the hero went to fetch water, villain came and the rope was left out, but it used to fall inside, but here it doesn't fall. Why? You want to try it? Why? No, mass is not heavy, very light. This is very heavy. Not very heavy, very light. I can do without even ordinary thread also. My child, you have just picked the words. Force, energy. Ungal veedenge, ungal veed munnale. Nama veedenge, ungal veed munnale. that's funny. हाँ. Now, this is the beginning of the class for the most difficult topic in motion called the conservation of angular momentum. What is happening so fast, you can't see it. I'll give an explanation, but I'll show more in detail with other things I have got. What is happening? When I leave this small weight, it is moving down. It gains circular motion, correct? That means certain amount of angular momentum. And as this weight is pulling down, the rope is becoming shorter and shorter. As it becomes short, angular momentum has to be conserved. This length is becoming short, that can only be compensated by increasing the speed of this. mr omega dot. M is the mass, r is the radius, omega is the angular velocity. When it starts with certain mr omega, r is becoming small, small, small. Only mass cannot change. The only thing which can change is the angular velocity. And as it becomes very short, angular velocity becomes very fast. And it goes around the third law of conservation of angular momentum. I'll show you something more. वो मंजिल का है. I wanted to also show before I went to that, there's a very simple toy sold in the market. It is called the Newton's cradle. Newton's cradle. It is one of the best toys. If Newton would have seen it, he would have been very happy, because the movement of this toy, even Newton could not have predicted. Newton knew the law of conservation of momentum, but Newton did not know the law of conservation of energy. Because during Newton's time, energy was yet to be defined. So all he had only one law to work with, conservation of linear momentum. Newton did not know about conservation of angular momentum. Only Kepler knew, but the word was different. So this is a very interesting toy. You see the functioning. I will ask the cameraman to watch here. I'll bring it to the back. If I pull one of the ball, there are 5 balls. If I pull one, only one goes out. If I pull 2, what will happen if I pull 3? Just see, it's a very simple toy, but if you can learn the phenomena, science of motion becomes very, very easy. Just, anybody can hold for me? Come, come, come. Come there also. Hold it carefully. Camera, can you see it? See, I'll pull one of the ball. When the ball hits, only one ball will go out. I take 2 balls. Then it's 5, I take 3. Astonishingly, one ball which was coming goes with it. When I take 4, oh, sorry. You understand this? It's one of the finest physics demonstration on motion, conservation of momentum and energy. I told you, even it's called Newton's cradle. People keep on their desk in the office and play with it without understanding anything. The Chinese have made it very simple, 200 rupees or 300 rupees in the market. can see for yourself. It's one of the most beautiful toys to explain. Anybody can hold for me? Come. Hold it carefully. Just keep it like this. Camera is there, no? If I pull one ball, only one ball goes out. If I pull two balls, but the best comes when I put three balls. And another thing is there. If I pull two balls and leave it like this, sorry. And once you watch it and solve the equation of motion, all the balls are of same size, initial momentum, final momentum equal. MV is equal to, two balls are there, M1, V1, MV2 is equal to initial MV. And kinetic energy, MV square is equal to MV1 square plus MV2 square. Solve it, you'll get the answer. What is the velocity? Why does the first ball stop? If you don't want to buy Newton's cradle, take a carom board. Understand? On the carom board, put heavy books, form a channel. Put some powder. Put 5 coins inside the channel. Fire one coin, only one coin will go out. If you fire 2 coins from outside at that channel, 5 coins, only 2 coins will go out. If you fire 3 coins, only 3 coins will go out, however hard you fire. It will not be 2, it will not be 4. Why? And that is handled by 2 laws, conservation of linear momentum and conservation of energy. That is the power of this law which holds together. But it's a great fun. If you have a cannonball in your house, you can do it. Otherwise, I bought it in the market. When I saw it, I saw people playing in their office with it. I asked them, what are you doing? That is the typical answer we get. So that comes to motion. Forget it. What is the time? Oh. I think I'm still running well. There are so many things to talk and so many to raise. I'm already reached 12:20. Should I change the topic to go up to chemistry a bit? Because we have done a lot of physics. It gets boring after some time. So I do a very simple experiment. So simple, it was done 2000 years back by a Greek engineer called Ptolemy. Until now, our textbook gives funny answers about it. 2000 years back. It's good to demonstrate. Can you put this in center? Get a candle, the jar. उसमें तो बेकिंग पाउडर डाल दो नहीं अंदर नहीं है bring a plate any plate is here a candle a plate can anybody help me to switch off all that fan because when I'm burning a candle even the front fans for a while it will be hot but for a while we'll switch off the fan so that the candle can burn. Today I'm going to perform a very simple experiment. This experiment was done 2000 years back by a Greek engineer called Ptolemy. 1600 or 1800 years later, it was repeated by Galileo. And finally, in the 17th century, it was done 18th century by Lavoisier. Have you heard the chemistry people the name of Lavoisier? What did Lavoisier is credited with? Discovery of oxygen. Who is that person? You get a pen. Kindly pass a pen to him. You can go and collect it. Good. Collect it. So, I want to show you the status of science, how pathetic it is. Something was done 2000 years back. repeated after 1600 years by Galileo, done in 18th century by Lavoisier, and a final conclusion had come, but still our textbook talk what was talked 2000 years back. I do not know why. Let us see, I'll demonstrate before you. Lighter pencil, huh? A plate, any plate is there? कोई भी plate, that any plate anywhere, this will do. I'm taking a plate. Get me a bottle of water. Please forgive me because you know, this is not a regular laboratory. Half the thing I was coming, I brought my friend to help me. Wait a minute, before you light it and fit it here. My friend helped me because many times the magnet, etc., is not allowed in the aircraft. I came by the morning flight. So my friend Suresh, who takes a lot of interest in these matters, said, sir, I will take the... But everything is confusing a bit. Not because things are bad, but you are so bright, so everybody's interest I have to keep in mind. 500 people. Now, I've got a tray. I've lighted a candle here. Very simple experiment, but don't be in a sure. Answers will be very funny. I fill this tray with some water. I know everybody must be feeling very happy, very simple answer. I'll answer it immediately. Don't be so sure. Observe and think and answer. All of you have studied in your class the experiment I'm going to do, but like the sun moving around the earth and earth moving around the sun, the answer may surprise you. So think carefully before you answer. Observe carefully. The experiment is very simple. I've got a flask here. Here is a candle burning. I'm going to cover the candle with this flask. This was done 2000 years back when they believed there are 4 elements: earth, air, water, and fire. And what Pilmi did, he did this experiment just slowly. The fire keeps burning for a while. It's still burning. Still fire is burning there. And slowly the fire is going out and the water starts rising. Can you focus on this? You see the water is rising in the... It has come up to the level of the top of the candle. See? The Pilmi had to answer why. Can anybody of you answer why the water is rising? Very simple. Very good. Somebody has raised the hand. Tell me. Think and tell.
Sir,
Sir, the volume is very, the interval is very high, sir, so the volume is occupied very less in the
Kindly sit down.
Sir, because of the oxygen, because of the oxygen present in the atmosphere, because of the absence of the oxygen.
The oxygen has been consumed. Here we have got a very good answer, but answer is because the oxygen of the air has been consumed, there is a vacuum created and the air is, water is filling that. Am I right? That's a very good answer, but not right. Anybody you try the,
it is because of the absence of oxygen, sir.
Absence of oxygen. Oxygen has been consumed by the candle. That's why an absence. Why is oxygen absent?
Because of the jar.
No. You tell.
Because oxygen supports combustion, sir.
Okay, oxygen supports combustion. Why is the water rising? I'm not asking what supports combustion. No capillary. Capillary is very, no.
It's displaced by water, sir.
Air gets this. Why? If I remove the candle and just keep a jar, will the water rise? Sir. Anybody, I even don't want mind if the teachers also participate.
Sir, when we burn the candle, the air gets heated and the air gets lighter, sir. Due to the lighter pressure in it, the water moves from.
Again, we come slowly. Candle is burning.
Yes, sir.
I cover it.
Yes, sir.
Air gets heated, but it is inside the.
Yes, sir. It is with less pressure, sir. So water.
Where does the air go after getting heated?
Inside, sir.
It is inside only.
Yes, sir. It's with less pressure, so the water tries to move to the.
Less pressure less pressure will only happen if it's allowed to expand. If the air gets heated and allowed to expand, but it is a closed space.
The air gets lesser, sir. The space gets lesser inside.
How it is lessened?
Sir, when air gets heated, it moves
It
to.
has to expand, but there's no expansion space. No, it's closed.
That space is occupied by the water.
You are coming but not guided. See, I've got air here. It's a cloth from below. I heat the air. The air will expand, but if there should no space to expand.
Sir, when the air expands, the
No. Air will only expand when there is a place to expand.
air will get lighter, sir. So water.
No, my son, no, my son. It only becomes lighter by expanding. And for expanding, there has to be a place available. Good, huh?
The candle is burning inside the plaster. The oxygen gets burned, sir. Due to that, the low pressure inside the
But oxygen, one way, very good, but not correct. Sir, increase of carbon dioxide. When?
ப்ரெஷர் வந்து உள்ள இந்த இது இருக்குல்ல அது கம்மியா இருக்கனால
Why கம்மியா இருக்கு? ஆக்சிஜன் போயிட்டாரு.
Sir. So the air gets sucked. So the water gets sucked in when the air, among the air, oxygen is burned by the candle, sir.
Very good answer, but not correct. I'll tell you why. Sir. Children, just pay attention. I got one simple answer in different languages, different words, but one simple answer. And that is available in the textbook. And that is also available on the YouTube. And it is absolutely wrong. That's why I say knowledge from YouTube and WhatsApp are dangerous. Not because of lot of information, but lot of misinformation and lot of disinformation. I'll show you. Anybody help me here? Can you repeat? I'll show you why you're wrong. And that's why I told you this experiment was done by Ptolemy, by Galileo, by Lavoisier. And all three came to a different understanding. Three great scientists of the world have done this experiment. Looks very simple, like the pendulum. I'll show you why. My friend, can you draw this experiment? Draw a plate, straight line. Just draw like this. Long, huh? Draw a small candle here. Just good. Just one line. That's okay. Good. Candle and draw the jar. Full top. Take it out. Very good. You got a good hand. I'm very happy because simplicity of drawing and done so fast. Now see, my friends, the answer which I got from everyone, including our chemistry teacher, ma'am, has got any different answer what the children are telling. Because this is a very fascinating experiment. Watch, please. What most of the children answered, except one boy who was on a different direction, very right direction, not fully right. One is when the candle is burning, it is taking oxygen from the air. What is candle? What is a candle? It is a hydrocarbon. Am I right? it has got a formula like that, CnHm something. Am I right? Any hydrocarbon will have this formula. Carbon and hydrogen. But a rough formula. So when the candle is burning, C will take an O2 from the air, it will become CO2. So one oxygen gone, one carbon dioxide come in. One molecule gone, another molecule come in. Correct or not? But not that only. Hydrogen will also burn. 4 hydrogen will take one oxygen. 4H plus O2 will give 2H2O. So one carbon will take one oxygen molecule, give back one carbon dioxide. 4 hydrogen atoms will take one oxygen molecule, give 2 water molecules. So instead of less molecules, there are more molecules there. Oxygen, total oxygen lost 1, and C plus O2 is equal to 1 and 2. 2 oxygen molecules you lost from the air, and in return you got 1 molecule of carbon dioxide and 2 molecules, 3. So for every loss of 2 oxygen molecules, you're getting back 3 molecules. The water level should go down. Air is becoming more dense. You follow my point or not? This is a very simple mathematics. You will be not knowing whenever you burn fire, 1 kilo of candle wax will give you 1 kilo of water. Do you believe it? Whenever your car is running, 1 liter of petrol produces 700 milliliter of water. You see jets flying in the air. Sometimes you'll see a white smoke. That is because of the steam coming out from the engine, which is getting immediately, the cold air is, the vapor is coming back to vapor and cloud. 1 liter of petrol produces about 700 to 800 ml of water. So, but why does it rise? This answer was given by very simple change in experiment. ने एक फ्लोटिंग कैंडल था, ऐसे डिब्बे में रखा था. नहीं, एक छोटे से फ्लोटिंग काले रंग के डिब्बे में कैंडल था. ये what Galileo did, Ptolemy did the experiment, initial experiment, final result. Galileo was a keen observer. He said it is not important only to see the beginning and the end. It is very important to see what is happening in between. That is the power of observation. So he took a floating candle. I've made a floating candle. There's a small cap, a piece of candle, and see how different it becomes. Suresh, where is it? Can you light it? Take that side, light and bring it. This is another way, and this experiment led to one of the most common things you use in medicine. When you fall ill, what do you use to measure your temperature? Thermometer. And the thermometer was first discovered by Galileo while doing this experiment. Float it, float it. Is it floating? Leave it, leave it. What he did, focus the camera on it. He did it repeatedly hundreds of times and observed. Watch carefully. As I am lowering it, because this is already full of carbon dioxide. Again. I didn't clear. Carbon dioxide is heavy. It remains inside. I have to, even when I'm blowing more carbon dioxide inside. I had to have another jar, but anyway, I'll try again. I think I've disturbed it enough. See, these are the things which make your experiment go wrong. I forgot. I've done a chemical experiment inside. There's more carbon dioxide inside here. I kept the like this. All the carbon dioxide is settled here. And the candle experiment proved wrong. Again, I'll try. Lot of bubbling is taking place. Can you see? Oh, you've not missed the point. Can you focus on the water? If you do it at home, you will see, however carefully you put the, this what you call flask, the moment it touches the water, a lot of bubbling is happening. Because the air above the candle, when the candle is a very, very hot air, it is already expanded, not tried to expand. It's expanded. It's a very thin air above the candle. As you cover with it, and when you are touching it, the air is still expanding, it bubbles through. But when you put it down, bubbling stops. So when Galileo observed it, he did it many times, he could not stop the bubbling. And he came to the conclusion that it is a hot air, there is nothing to do with oxygen. The air above the candle is very hot, we cover it, we trap a hot air inside. And when he also saw the water is not rising when the candle is burning. If you notice again, if I do it again, the candle will be there, the water will be there. Till the candle is burning, the rise of water is very little. The moment candle goes off, suddenly the water rises. That is because of the atmospheric cooling of the air. The air contracts and lets the water rise. And seeing this result, Galileo made the first thermoscope, which later became the thermometer which is used now. Now we've got digital thermometer, but the earlier thermometer of a mercury expanding, before that it was only a bulb and a long tube. How an ordinary observation led to such? But the main revolution came in the field of air when the Boyle's law. Have you heard about the Boyle's law? All of you, anybody? Expansion of gases, Boyle's law, Charles' law. Any idea? You heard about Boyle's law? So, okay. I'll connect another experiment with Boyle's law and let's see after that what we can change. Because I've got no end of experiment, but the time is running out. But we have got an afternoon session for the interested children. Please be comfortable. Suresh, can you bring the eggs and hot water? Putting it, sir. Switch it on. Can you peel this egg very carefully? Don't break it. I've got 2 eggs in my hand, boiled eggs. I want to show you the fun of Boyle's law. I've got 2 eggs in my hand. I'm giving, please peel it without breaking. Anybody who wants to peel it carefully, don't break it. Just peel it, remove the skin. No, don't want to eat it. Just peel it. Peel means remove the shell without breaking the egg. Carefully do it. Bring it to me to help me. Oh, you are feeling shy about that. Can you do it? Yes, yes. There's nothing to feel shy in peeling an egg. This is another very simple experiment. Medua paninga. Don't break the egg. I want a smooth egg. Not able to do it? सुरेश, इसको खोल के निकालो. इसमें पानी भर दो जरा. Just can you fill some water up to here? Acha. Before peeling the eggs, I'll show you an experiment how gravity establishes the motion of the planets around the Earth. Gravity is pulling, but yet the most planets go around the sun or the moon goes around the Earth. What makes it go around? I got a small model. I made it at home. It is a very good model of planetary motion. How it happens? I'll show that because they're taking time in peeling the egg. Ready? Okay. The water is getting boiled. Can you give me that? This is a very fascinating experiment I want to show you. Here I have got my granddaughter eats gems. So I took the ball of the gems and made a sun out of it. Can you see it? This is a sun. S-U-N, sun. I made a small earth, green color. A small ball, the earth. This is from the gems. Children eat, my granddaughter eats a lot. So I got that ball, made a, and then I connected a tube. U-tube, made out of plastic, but it became one of the best models of planetary motion. You see, there is water here connected with this, see, as if it is pulling it. If I leave it, as if gravity is pulling, see, the sun is pulling the earth. But the moment you leave, it goes inside the sun. But normally the earth is, because of the pull, is not going inside the sun. It's going around the sun. Am I right? Why? What's this? This is for this class first. See it carefully. If the earth is here, and the sun is here, and if I leave it, it will just go inside. But now suppose the earth is coming from somewhere and going somewhere. While going, it meets the sun. The sun starts pulling it. What happens then? See. You see? It starts rotating. I'm not rotating it. See? You understand? Because though this is not the correct model for gravity, gravity reduces with length. This is a fixed gravity, but it is a radial force towards the sun. See again. Ready? Ready? Just see, please. This is the sun, this is the earth, and this weight is acting as gravity, pulling the earth. But suppose the earth is from somewhere, going somewhere, and I just leave it. It's going round and round, and why it is slowing down? Because of the air. In space there is no air, no friction. The earth will keep going round and round. This is a very simple model to explain how gravity leads to planetary motion. I have not rotated it. It is because of this pull happening. The same pull happened in the cup. This is called the conservation of angular momentum. You can make it for 5 rupees or 2 rupees. You eat the gems, make the model. Very simple. This is ordinary glass bottle. It has an advantage. I can change the weight by the level of water. पानी रेडी हो गया? हॉट है हॉट पानी हॉट हो गया कि नहीं Keep it here. Which is the best? I think this is best. This is one experiment which is very simple, but many properties of the air, it gets revealed here. Everybody can do it at home. I've got a boiled egg. I have a flask, empty flask. The egg is much bigger than the egg is much bigger than the mouth of the flask. My task is to put the egg inside without breaking the egg. If I try to push it, the egg will break, isn't it? This is a flask, boiled egg. But explanations are difficult, I know that. I will not go on a paper now because you have said it. But the question is, if burning paper can bring down, why not pushing? I try to push it. But how does paper bring it? My hand is very powerful than paper. I am trying to push it. The moment I push it, it starts breaking. Why? Why that it doesn't break then? It's good to speak, but think before you speak. There is no carbon dioxide here. I am not burning the burning paper. Not carbon dioxide. Why should carbon dioxide suck the air? Okay, but carbon dioxide will not suck it. Your hand cannot push it. Your hands are powerful. Huh? There is no vacuum. I'll see. I'll show you. Huh? Tell me. That's what it is. It is all the time trying to go inside the sun, but because of its horizontal velocity, it is missing the sun. I'll give an example. Listen to me very carefully. You've got to ask a very good question. You should get a reward for a question which you'll get it. Suppose I'm standing on the earth. I throw a ball. Where will it fall? After some distance, correct? I throw the ball even harder. It will go more distance. Suppose I've got a powerful method of throwing a ball around, say, 12,000 miles. Where will it fall? It will go around the earth and come back where it is. Keep increasing the distance. Earth is round. The earth starts falling toward the sun. But while it is falling, it is moving also. So when it comes, it misses the sun. Again starts falling, it misses the sun. So all the time the sun, the earth and with respect to the moon is falling toward the earth. It's always falling, but missing. I'll demonstrate on the board. You will find it very interesting. Very good question. Take the reward. I'm coming. The boy is coming. Finally come. I'm very happy. I got a very good question from a boy here who's getting an award. I'm more happy than the answer. A right question is the beginning of a good answer. Can anybody help me rub it? Kindly rub it. The question asked by my friend is, when gravity is attracting, how come Earth is going around, not falling inside the sun? I'll explain you, listen carefully. Suppose this is the Earth or the sun. I put it the Earth. What is happening between Earth and sun is happening between moon and the earth going around. I am standing here at this point. I throw a ball. What will happen? The ball will travel and fall down here, correct? I throw it still with greater force. What will happen? The ball will travel and fall down here. It has to fall on the earth only. I throw it with enough force. Again, the ball will travel, fall here. I increase the force further. The ball will travel, and fall here. I again further increase the speed. You can calculate mathematically. And finally comes a speed when the ball will travel, and come back here. Starting point. Again it will travel because of high speed. It is not, you understand why it falls. When a ball is released here, it doesn't fall straight. When you throw a ball, it goes curve. Why? Gravity is pulling it down, horizontal velocity is taking it like that. When both combined, you get a parabolic structure. As you increase the speed, that is what happens when ISRO sends a satellite. The satellite is given a very high horizontal velocity, it keeps going around the earth. Wonderful. Now coming back to this, when this task was given to me, there's a lot of lesson to be learned. It is available on the YouTube, but the explanations are wrong. And you can do it at home. So when I was told, I thought I'd expand the glass by heating it, and when the mouth will get expanded, I can put it inside. So to expand the glass, I took hot water, put it here. I got boiling water, very carefully. Bring a bucket here also. I am filling the flask with hot water to expand it. Can you bring a bucket here? About it. You see, I tried to expand, very hot. I tried to expand the glass and I'm putting the egg here. But the expansion is very little, still cannot go. Then I throw away the water, I'll think of some other method. Wait a minute. I threw away the water. No, okay. I threw away the water and I kept it here and I'm waiting for some other method. Somebody was telling me I will have to light matchstick inside. Correct? Who told me? Somebody told me matchstick. I am not lighting any matchstick. I just kept it here waiting for any other method. Can you find a method of putting it inside? Huh? Why didn't it was going earlier due to atmospheric pressure? It has already gone inside. Due to expansion of the glass. No, it wasn't, because when I kept it, it was not there. See, it is inside. How do I take it out? How? Break the glass. Again by lighting matchstick. I have not lighted any matchstick. Right here again. I never lighted a matchstick. No, I turn it upside down. Okay. I can, but the job is to bring it out without breaking it. This shows the property of the air. I will do a very simple thing. I'll blow it here. Okay. What will happen? And then? Huh? Right? I'll do a simple thing. I'll just blow some air inside. Why? Air pressure is the same. See, watch me carefully what I'm doing. What happened? Egg has not come out. It's still inside. But can you catch it? You can? I thought I'd get you. Can you catch it? Oh, sorry. The egg came out very easily. If you look at the explanation, it is very, very fascinating explanation. When you keep the egg here, if you try to push with your hand, it will break into pieces. Because when you are applying pressure with your hand, you are applying at only one place. Air pressure has an advantage. It applies pressure from all sides, equally. So when I heated the flask with water, the whole flask became very hot. The air became hot. When I kept it here, I was walking in there, the air starts cooling. Because of the air starts cooling, there is a higher pressure more than that. The egg has got air inside it. That air expands and makes the egg from round to oblong. You see the... And there's a very beautiful story about it. When I was a small boy, I had a grandmother, no education, but very intelligent. So one day I was sitting with her in the house, in the ground floor, in her room. Suddenly she looked at me and said, Anup, mele poite, in Hindi she told, I'm telling in Tamil, mele poite, collect all the cloth drying on the terrace and immediately bring it. I told Pati, why? She said, Made poiporar, it's going to rain. I was astonished. What do you mean by Made poiporar? We are all sitting, we don't see anything outside. How did my grandmother know it's going to rain? I asked her, how do you know it's going to rain? She said, Pesa malir to udne ponga. So we ran, we brought the cloth. By the time we brought the cloth down, it was heavily raining. A sudden storm. Then I asked my grandmother, it's going to rain. And her answer was baffling. She says, what do you call it in Tamil? Knee? Mutti. My mutti is paining. Inna mutti is paining. Inna sambandh made koi porare. I thought she has gone mad. But she was right. Why? Our body is full of air. All places. Air pockets are there. When suddenly the air pressure drops in a storm, the air inside our body expands. And young age, our body is very flexible. Expansion is taken care of. But in old age, the body becomes brittle. The expansion causes pain. And she had big air pockets probably in her knee. The knee starts paining and she will come to know Made Poiporar. It's a very, very interesting thing how in day-to-day life, physics gets connected, chemistry gets connected with everything. This experiment you can do in number of ways. You take this, keep it in cold water in the fridge. Just keep this in fridge, the egg will go down. Oh, it's still going down. I can't pull it out now, see? It has become like a cork. You can't even pull it out. If you pull it, it will break. Slowly, don't break it. It's difficult. So that is why it is happening, because the air inside the egg expands, changes the shape of the egg. Our whole body is full of air. क्या टाइम हो रहा है? हाँ सर, we can have the lunch. We are doing well. I'm sorry, I delayed your lunch because 12:30 you got lunch hour. 1 o'clock. Okay, right at 1 lunch. I don't want you to miss the lunch. Maybe if I have chance, I'll meet after the lunch. And if you find it interesting, do come. If you don't find it interesting, free to go home. So they are telling me it's time for lunch. Time passed for me, I do not know how. For you, I do not know what was the result. But I got, next portion will be dealing with electricity, magnetism, and light. Okay, all the best.
Thank you, sir. I can be sure that you've inspired a lot of students with the session in the morning itself. So this is lunchtime for us, students and teachers. So please assemble in the dining hall for your lunch. So we request you to come back by 1:45 for the afternoon session. 1:45.